So now this is reading the input, which is very nice. Let's create a function that moves the snake. So before that, let's just print self.movement. All right, just to make sure that this is working properly. So now here, if you remember, we're going through all the events, and then here we're saying if the event.type is equal to a quit event. We can also check for another type of event, which is a key press event. So else if event.type equal pygame dot, so pygame dot key down, meaning a key is being pressed. So what we want to do is take our snakehead object and then use the read input function, read input that we just created, and pass in the event dot key. So we'll pass in the key. So if we do this and run the program, so let's just move it on the side, okay, and take this panel right here. Let's say I'm pressing W. As you can see, it printed up. If I press A, it says right, which it should be left. So I made a mistake right here. So it should be left, right, up, down. So let's just exit, Control C, run the program again. So here W is up, D is right, S is down, and A is left. So now we can read the input properly, which is nice. We can also add like the up, down, right, left arrows. So let's do this. We can say this key is equal to pi. We can say that key is equal to pygame dot k underscore A. So if the key is the A key, or if the key is equal to pygame dot k underscore left. So or the key is the left. We press the left arrow key. So if this is true, if this condition is true, or else this condition is true, set the variable self.movement equal to left, which is a string, right? So we can say the same thing for D. So let's replace it with right. Say the same thing also for W. In this case, it's gonna be up, and here again, it's gonna be down. So let's run the program right here. If I press the left arrow key, I get left. If I press the right arrow key, I get right. The down arrow key, I get down. Up, I get up, and so on and so forth. Right? I can use the keys, or I can use my AWSD keyboard input. So let's exit from here, and let's try and move our snake head. So let's create a function, call it move the head, and this should only take a self object. So let's go in our initialize function, init, create another variable, call it self.speed. Alright, so this is going to be the speed of our snake head. Let's make it equal to let's try and make it equal to 2. Alright, because I don't know how it's gonna go, so let's just try and make it equal to 2, and say if self.movement is equal to, let's say, right, what we want to do is set the variable self dot position x plus equals the self dot speed variable. So just keep in mind that this means the same thing. So this is the equivalent of saying self dot position x. So our position, move our position by so add the speed to our position x. So let's say our position was 0. In this case, it's going to be equal to 2. If the position was equal to 4, it would be equal to 6. So on and so forth. So we're just adding the speed value to our position x value. Now let's make an else if statement. Else if, and copy this. If else if our self.movement variable was equal to left, right here, left. So what we want to do is subtract our self.speed from the position x. Alright? So this takes care of our x, of our horizontal movement. Now let's go on to our vertical movement. So let's say self.movement was equal to up. We would want to take our position y and subtract self.speed from it. Not add, subtract. Because as we go up, here, as we go up, y decreases. As we go down, y increases. So if we go up, y should decrease. That's why we're subtracting our self.speed from our self.position y variable. So let's just make it like this. And now let's create our final else if statement and take care of our down movement. So if the value of our self.movement is equal to down, then we want to add right here. Then we want to add our self.speed to our self.position y. Now this should work fine. Let's just go here and move our snake at every frame. So let's just say sHead dot move. Right after we draw it, we move it. Or we could do the opposite. We move and right after that we draw. Let's go to our program directory, our game folder, and then let's run main.py. So just here, watch out, something interesting is gonna happen. As you can see, I can control the movement. However, besides the fact that it's very slow, what do you notice? Well, every time it prints the new snake head, which is our square, it doesn't get rid of the old one. So we have like a long snake effect, a long tail effect, which is not what we want. Alright? Well, first let's change the movement speed. Let's make it like, this was very slow. Let's make it 2.5 times faster. I think 4 FPS is a bit slow. Let's make it 8. All right, right here. All right, so the thing is, let's make the speed a multiple of 8. So we can say if the speed is 8, each time it's gonna move by half its size, right? So if we say speed is 16. Each time it's gonna move by its entire width. So this should make sense. Alright, so this makes sense. Alright, so we have like a snake effect, and each time it moves by its width. So, alright. Now what we can do here is use the same line right here. So we're just set the display to be entirely white at each time. So this just clears the display and then we print on it. So this should take care of our big line effect, right? Our wiggly effect. This should take care of it. And now, as you can see, our cube is moving very smoothly and very it's very accurate as a representation of the original Snake game. So now we have a moving cube, alright? The only issue is if I go all the way up to the left, it disappears. And we don't want that. So let's pass in game over, alright? Game over. Let's add this as a parameter and go into the move function and add it here, alright? So let's call it game over. Game over. And then let's check here if self dot position x is less than 0 and so basically if we're hitting the corners, so if it's the x is less than 0 or the x self dot position x is greater than the screen width, then game over should be equal to true. Alright, so basically if our x position or if it's less than 0, meaning we went offside by the left, or if it's greater than the screen width. And here since the x position is always the top left corner, when we're checking we should always add half its width, so 16 divided by 2. That way the moment the right side touches, we can evaluate that we have touched the right side of the screen. And then let's say else if self.position y is less than 0, meaning we went offside by the y, so we went over the top, or self.position y plus 16 divided by 2 is greater than the screen height, then game over is also equal to true. So basically in this case, no, let's remove game over. In this case all we have to do is just restart the game. So let's just say for now restart, and then again restart. Right? So here instead of game over we need a screen width and a screen height variable. So let's go ahead, instead of passing in game over, let's add the screen width and the screen height. And then here let's say restart. Let's run the function called restart. Alright, create a function, call it restart. So define restart right there, and then let's just copy all of this. Alright, so all what restart does is, in theory, we should just change the position self. Let's put self here, self. So what restart does is it sets the position X. So self dot position X equal to screen width, the previous one that we explained earlier, and self dot position Y equal to this one right here. So that restarts the game. Basically, whenever we exceed the corners, all we do is set the position X and the position Y to the original position X and the original position Y. So here you have to say self dot restart and self dot restart again, because you're calling a function that's already defined inside the scope of this class. And each time we're calling on a function or a variable that's defined in the scope of this class, we have to use the self dot to call that function or variable. Alright, so now we just have to save it and run it on the command line. So let's run this and try it out. So hopefully whenever I exceed the corners, you will see that the character, okay, it says that screen W is not defined. Alright, and the error happens to be okay. So here let's add screen width and screen height as parameters. Let's enter 1280 for the width and 720 for the height, and 1280 and 720. So I pass in these parameters into the function, and the function will use them to respawn our player. So let's go ahead and run it, and then let's exceed the corners right there. And as you can see, the moment I touch the corner, I respawn. However, you can see that it goes a little bit further. And this is because we're dividing by 2. And this is not correct. We should actually make it 16, so that it adds its entire width and it checks at that point instead of dividing by 2. So that's a small mistake we need to correct. Now let's stop it and run it again. Main.py, and now let's try again. And boom, the moment it touches, it restarts. Same thing for the top, the left, and the right. So that's it for this tutorial. In the next video, we're gonna add a fruit and maybe start working on the tail. So thanks for watching, and I'll see you in the next video.